Alright guys, it's 8:35. Alden has an announcement to make.
Just want to say, with Hack Challenge coming up, we have a Hack Challenge matchmaking mixer this Friday at 4:30 p.m. that is mandatory. I guess if you can't make it, reach out to me, post on Ed. But that's where you'll get to, meet your potential team members and select your Hack Challenge. In Gates Geo1. I'll make an announcement later today with that stuff on Ed, but I figure I might as well just announce it now. Yes. The Hack Challenge starts next week? Starts next week, on Monday. Cool. Without further ado, Vin.
Alright, so just to recap, last lecture we learned about SwiftUI, the difference between imperative and declarative UI. And I introduced how we create views in SwiftUI and how we use modifiers to modify our views. And we also learned why SwiftUI uses structs for views instead of classes. And then we went on and talked about layouts, which is how we position our views side by side on top of one another. So now I'm going to quickly recap what we learned about layouts using this app that I worked on this semester called Volume. So as you guys can see, it's scrollable. I'm not going to go too much in detail about it, but if we were to look at this view right here, you can see that this thing is laid vertically. So I would use a V-stack, but inside of this, or this V-stack will be nested inside of an H-stack, because these things are laid horizontally. And because this entire thing is scrollable, we can see that you can use either a list, a scroll view, but in this app I used a list in this case. But so yeah, you can use, there's this thing called a lazy VStack where you can attach it to a scroll view so that only your views will only be loaded whenever it's on the screen. So that helps with performance. So yeah. So today I'm going to talk about navigation. So in UIKit, to go from one screen to another, to go from one navigation controller or view controller to another, you use a UI navigation controller. In SwiftUI, you use this thing called a navigation view. In iOS 16, they actually changed it to a navigation stack. But basically, remember, everything in SwiftUI is a struct. This navigation view is a struct. So inside of this navigation view, I have a text, which is also another struct called appdev. And what this navigation view does is that it presents a stack of views that represents all of the views inside of this hierarchy. Alright. You can also add modifiers because remember, this is also a view. And remember, every time we're adding a modifier, what SwiftUI is doing is creating a brand new view. So these are some of the modifiers that you can add to your navigation view. You can set the title, you can change the display mode, you can change the bar buttons. There's also this other view called a navigation link, which is a view that controls a navigation presentation. So this is similar to in UIKit pushing a view controller. You can also present a view in SwiftUI, but you will be using this thing called like a sheet, but I won't go over that in today's demo. So as you can see, I have a navigation view, which you guys can think of as a stack containing all of these views. And inside of that, I have a view called navigation link. And right here, I have the view that is being presented. So this is the view that I will push. And for this label, this thing is called a trailing closure. And this label is a view that I will tap on. And when I tap on that view, it will push, or it will push this view onto this navigation view stack. So I'll quickly demo using the app that we started on last class. So last class I didn't really go into too much detail about using Git, but I'll try to make it a lot more clear this time. So first you want to open up terminal. You can do command space as a shortcut and then just type in terminal. I'm gonna zoom this in. All right. And you want to go to the directory that you have your repository in. So for me, I have it in my app dev folder, and the name of the repository is called Birdwatch. And so to check out a branch, I would do git checkout, and for today's starter code, you will do to-starter. Click enter. I already have this branch checked out, so that's why I got this message. But if it's telling you to stash or add a commit, then what you want to do is git stash. Because I don't have any changes, it doesn't save anything, but you can do git stash, and then you can type git checkout to-starter. All right, does anyone have any questions? All right. So this starter code is a bit different from last class. It's the exact same thing. Remember how I left off with this bird list view that contains this list containing all of these bird species? Well, in content view, all I have is this vertical stack containing this image, the name, location, and the count, which are all text. And I put that inside of a group so that whenever I add this modifier to this group view, it applies it to every single view inside of this group. And I also have a button called ViewBirds button, which is just a text with a padding and a background color of blue. And this clip shape just basically makes it have these rounded corners. I use a rounded rectangle. So yeah, I won't go too much in detail about how to use this. You can always Stack Overflow. So yeah. So what I want to do is, if I go back to the demo, hit play. If I click on that View Birds button, it pushes a new view onto the screen. So what I'm going to do is this vertical stack right here, I will nest this inside of a navigation view. You can also use a navigation stack, but in this demo, I'll use a navigation view. So create a navigation view, and the content inside will be this VStack. So now everything looks the same because all I did was just add this to this navigation view stack. And so now I want to add a title to this navigation view. So a common mistake that a lot of people make whenever they're using navigation views in SwiftUI is that they add the title to the actual view, its navigation view itself. But you don't want that. You want to add it to the views that are nested inside of this navigation view. So I will do dot navigation title. This is a modifier and it takes in some text. I'll just put Birdwatch. As you can see on the right side, the live preview, I have this navigation title. So what this does is that this view, which is a VStack that's inside of this navigation view, I'm saying, hey, with this VStack, give it a navigation title of Birdwatch. I'm not applying this modifier to the navigation view. I'm applying it to the view inside of the navigation view. So now that I have a navigation title, what I want to do is push this bird list view whenever I click on this button. So we will use a navigation link. The link that I want to apply to will be this View Birds button view. So what I'm going to do is create a navigation link. Inside of this will be the destination. So in the destination would be the bird list view. and I need a label for it. In other words, a view in which I will tap on to push this bird list view. So I will use a trailing closure called a label. Note that there are a lot of different ways to do this. This is just how I do it. So a trailing closure of label. The label will be the view birds button. So now, if I were to tap on this view birds, it pushes this view controller. And I could add a title to this navigation view or to this list. So what I'm going to do is inside of bird list view, inside of this list, I'll give it a navigation title of, I guess, birds list. And you can't see it right now because the preview only shows you this view itself. So if I go back to content view though, and push this view, you can actually see the title. All right, are there any questions? All right. So now, this is the fun part of SwiftUI. I will teach you guys how to modify the program states. So, let me open this again actually. So, right now I have this add account button. If I were to tap on it, I want this count text to increment by 1 every time. So, if you guys didn't, or if you guys need to catch up, you guys can do git stash to save those changes, and then do git checkout to dash navigation to catch up. All right. I don't know what. Okay, I think my Xcode just crashed. Let me open it again. All right. So first, I want to create that add account button. So I'm just going to copy this view birds button, and I will just paste it right here. I will call it add count button, and the I don't know what's okay. Hopefully it doesn't crash again. All right, so I will create a button by doing button, and inside of this will be the action that I want to do. For now, I'll leave it blank, but then you need to add a trailing closure, just like how you did with the navigation view or navigation link, and I'll put this text inside of this label. And instead of add birds, I'll just say add counts. And I'll give it an orange background color just to make things different. And so now I want to call this view inside of this body property. So I will create an H stack, and I'll add that add account button. And then I'm just going to cut this and move it inside of the H stack. And remember, when you're using SwiftUI, it's important that you space out all your views with new lines so that everything is neat and easy to read. So now I have this add account button. What I want to do is increment this number count by 1 every time I click on this add account button. So what I can do is create some variable to hold the count number. So I can say variable count, I'll make it an int, and I can initialize it to, let's say, 0. All right, so now I want to use this count inside of this text right here. So I'll just do count in here. So I use string interpolation to add this count inside. So now if I click on add count, nothing happens because I want to increment count by 1. That's what this area is for. This is the action that I want to do. So, okay, let me increment count by 1. I can do count plus equals to 1. And what does it say? It's saying that self is immutable. So remember how this entire view is a struct? We know that structs are immutable. Their properties are, if you change a property, you're changing the entire view itself. But I want to increment this by 1. But I can't really change the struct. So what is the solution to this? Well, SwiftUI has this thing called property wrappers, in which you wrap your properties so that you can change the program state. So there's this property wrapper called @state. I will add @state to this variable count. As you can see, Xcode is not mad at me anymore. And so now if I were to click on this button, it will increment count by 1. Now, because when you use @state, you only want to use it within one view. So you're not going to be sharing this property to any other view. And that's why Apple recommends you to make this a private variable. And because this view owns this property, I can use @state here. So now I can still increment this by 1. So let me go back to the lecture slides. Alright, so in this part of the demo, I have the name and the location. Instead of a text, I will use a text field so that I can write to this, so I can change the properties. So if I type in Emily, and she's from New York, if I add the bird, check the view birds, she is added to my list. So that's our goal for this lecture, or for this part of the demo. Give me 1 second. All right. So if you guys need to catch up, remember git stash, and then git checkout to -button, and it will switch your branch. Okay. Thankfully, Xcode did not crash this time. Okay, I actually made the button green here, but same thing. So now I want this orange button to add the bird. So again, I'm going to copy this add account button, and I'll just add it right here. And I'll just say this is an add bird button, and remove this, call this add bird, and then make the color orange. Alright, and now I want to add this button to my view, so I'll just add it underneath add count and view birds. So beneath the H stack, I'll do add bird button. So in the live preview, you can see that there's an add bird button. So now I want to change name and location to a text field. So instead of text, I'll call this a text field. And this text field view takes in 2 arguments. One will be the placeholder, one will be the placeholder. So this thing won't work. I'll explain that in a bit. So I'll just change these into a text field. And so now, inside of here, I'll give it a text. And I will create some properties to hold this text. So I'll call this @states private variable. I'll call it name. it'll be a string, and I'll initialize it to an empty string. And then I'll do the same for location. Remember, make it private. Make that an empty string. All right. So now I have these properties. What I want to do is this text field, I want to change these properties. Okay, so why not pass in these properties to this text? So I'll put a name here, and then for location, I'll do text of location. But Xcode is still mad at me. So what is the issue here? Well, when I click on this add account button, it increments my count by 1. And it worked as soon as I changed these properties to @state. Then why isn't it working for these text fields? And the reason is because this text field requires a two-way binding. In other words, it's a read and a write. This add account button, when I were to click on it, it incremented my count by 1, but this button itself, it's only reading in that value. But with the text field, I'm changing that value and I'm reading it. So, to create a two-way binding, you will use a $ symbol on both name and location. And so, as you can see, Xcode is not mad at me anymore. And I can type in here just fine. Does that make any sense? Does anyone have any questions? Yes.
So when do you know to use the $ and when not to?
Yeah, so if you are using a view that also writes and reads, then you want to use the $ because that creates a two-way binding. But if you're just reading in your properties, then you won't need that $.
Well, I guess my question is like, where do you know like the view is reading versus when it's writing?
I guess that just comes with what you're trying to do. Like in this text field, you know that I'm writing to this text field, but it's also changing what I see at the same time. So in that case, that's both a read and a write. All right, any other questions? All right, so now what I want to do is, whenever I click on add bird, add this bird to the list. So what I'm going to do is, inside of this add bird button, this is the action that I need to do. What I'm going to do is, remember I have this list of birds inside of this bird.swift file. And I want to append a new bird. The name of that bird, I'll get it from this name property. And remember, you're not writing at all, and you're not changing the state. So I could just use name here. No $ needed. Location will be the location property. Image, it'll be, I have an image in this asset catalog called newbie. And the counts would be the value of the count property. And I also want to reset these values inside every time I add this bird. So what I'm going to do is make name, set it back to an empty string, set count back to 0, and set the location back to an empty string. So now, if I were to type in, I found a new bird, the species name is Emily, the location is New York, I saw her twice. If I click add bird, all these properties get reset. Click view birds, and she's down there. Yes.
The birds list, where is that defined?
Oh, this list of birds right here?
On line 56, birds.
Yeah. So this bird.swift file, I have an array of birds here. Normally, you would have a view model. I won't go into too much detail about MVVM. Are you guys familiar with MVC? Model View Controller? Yeah. In SwiftUI, we use this thing called Model View Model, which is a different architecture in which you create your views or your app. So normally this would be in a view model, but if any of y'all are interested, you guys can always come and talk to me right after. So yeah, now just to recap everything, I introduced a thing called a property wrapper, in which you wrap your properties so that you can modify your program states. So this @state property wrapper, you want to use it if the view itself creates and owns that instance. In other words, in that demo, that count variable, that content view struct owns that view and it created it. So in that case, I will use @state, and this only works for value types such as struct, enums, ints. So yeah, you also want to mark it private for best practice, because nothing should be modifying this property that you own. And you can use a $sign to create a two-way binding to the property. In other words, a read and a write. What about reference types? So this example that I just showed you guys, I was using a value type. I was using an integer. But what if I want to modify? What if my property is a reference type? So I'll demo. Oh shoot. Oops. Okay. Spoiler alert. But anyways, I'll demo. You guys don't need to follow along. This is just me showing how this works. Again, if this demo didn't work, you guys can check out. You can do git stash and git checkout to-final to catch up. So I have another demo. All right, before I move on, are there any questions?
Branch is to-final, right?
Yes. All right. So this app right here, if I can. Come on. Let me zoom it in. Can y'all see back there? Yes? Alright. So, what this app does is that this is a text field. If I were to change the values here, so I have Antoinette, but I can change it to whatever I want. It updates this text view. Same thing with the last name. It updates it. And what I used was this struct that contains a first name and a last name property. And I used the @state property wrapper that contains the instance of this user object. And the text field creates a two-way binding of the user's first name and the user's last name. And then, remember, this text does not create a two-way binding. It only reads in the value. So I don't use a $sign in this case. So now, what's the issue with this app right now? Well, structs, every time I change a property, I'm creating a brand new struct. So this user object, if I want to use it in other views, I could pass this instance along. But if that view is changed by one of my, I guess, subclasses or by another child, then that entire struct gets destroyed. But I want to use the same instance along every single view. I want to share the same instance. So instead of struct, what can I use? Does anyone know? Yes. Class, exactly. So instead of a struct, I can use the class. And the reason is because with classes, if I were to change these properties, first name and last name, that same instance it's still the same object. Okay, so let me try changing this. As you guys can see, it stopped working. I changed these properties for the text field, but my views are not being updated. Yes.
I think I checked out to final branch, but it still shows bird orange.
Oh yeah, this is a separate demo. There's no code that goes along with this.
Okay.
Yeah, so you can just watch. So yeah, I'm modifying the text field, but my properties aren't being changed. So why is that? Well, whenever I use the @state property wrapper, what SwiftUI is doing is that it's watching this instance itself. It's watching that value. If I use an int, if that int were to change, then SwiftUI updates my views. But when I had a struct, if I were to change the first name, this entire struct changes. And because the entire struct changes, SwiftUI knows to refresh these views. But in this case, I'm using a class. When I'm changing these properties, that class instance is not changed. And that is why @state only works for value types. But in this case, I want to use a reference type because I want to pass this user to different views. So, what's the workaround for this? Well, there's actually another property wrapper called @state object. So instead of @state, I'll use @state object. And for practice, you don't really want this to be private because you're sharing this instance to many views. But Xcode is still mad at me. It's saying that this user class needs to conform to observable object. So, with this user class, I will conform it to this protocol called observable object. That's all you need to do. You just say this class, your SwiftUI, I have this class called user. It's an observable object, meaning that you can watch these properties, and if they were to change, then you can update all views that use this property. So I can try changing it here, but it still doesn't work. And that's because there's one more annotation that I need to, or a decorator that I need to add to my properties called @publish. And I will apply it to both the first name and the last name. So now if I were to go and change it, as y'all can see, it updates. And so what this is really doing is that I have this class called user, and by making it conform to observable object, and by adding this @publish decorator to these properties, whenever this property changes, SwiftUI will update those views for me. And because classes, the entire instance itself is not changed when these properties are changed, then I will need this @publish to tell SwiftUI to update views whenever this property changes. Yes.
If you wanted to make it so that every time you entered a new character, deleted a new character, it wasn't updating the text label,
Mm-hmm.
and you wanted to add so you would type it in, and then you had a button at the bottom of the screen.
Yeah.
Once you hit that, then it updated that.
Yeah.
Would you not want the publish?
You could still use @published. Well,
Or maybe there would be several ways that.
yeah, there's a lot of ways you can do it. You actually don't need to make this. Actually, yeah, you still need to make this @published, but you won't be using. I don't think you'll be using a two-way binding. Or there's another way. You can remove this @published, and then you can still read it in that property. All right, you have a question?
Yeah, so does publish modify like the outermost object or just like the closest objects? Like if you have like a bird in a tree, like would it modify just bird or would it also like reload tree? Like if you have.
So you're saying that what if this class has a property that contains a different object?
Yeah.
Yeah. So @publish just basically says that this property, if this property were to change, then you will update the views. So if this at published were to be used on, I guess, a struct inside of this class, then if that entire struct changes, then it will change it. You can kind of think of at publish as at state, but for properties.
So it'll like update the entire thing.
Yeah. All right. So back to the lecture slides. So at state object is similar to at states, but you use it on an observable object, which in other words are reference types, and you apply this at published decorator to your properties so that whenever these properties are changed, SwiftUI is notified and it will update your views for you. And you want to use this if the view itself creates and owns the instance, similar to at states. This demo that I showed you guys, this content view owns this user object. I created it right here. So in that case, I would use at state object. But what if the view doesn't own the property? Well, there's another property wrapper called at binding. So you will create this property using at state in a parent view, and in the child view, whenever you receive this property, you will use at binding. So at state creates, and at binding receives. And it's similar to at state, but instead of creating this object, instead of creating the actual value, you can just say at binding variable. Well, in this case, this is a class, but it wouldn't work. But if I have like an int, I can do at binding variable like count. I can say that's an int. I won't initialize it because you initialize if you use at states. So it's similar to at state. You can use a $sign to create a two-way binding, which is a read and a write. And you want to use this for value types, not reference types. For reference types, so similar to at state object creates, at observed object receives. So this is similar to at binding, but for reference types. And similar to at state object, you have at published to notify SwiftUI that these properties, if they were to change, update your views. You do the exact same thing with at observed object. The only difference is that the views that use at observed object don't create the actual instance. Here, I created the user here. So I would use at state object. But if this were to be a child view, and I'm passing in this user instance to that child view, then I will make this an at observed object. It's not going to work here, but just to show you guys how to use it, you do at observed object, and instead of creating the actual instance, you can say its type is a user. You don't create it at all. And if my child view were to update this property, then the cool thing about this is that my parent view, because I'm passing this instance along, it will also update. So in UIKit, you had delegation, you had these protocols in which if you were to click on a button in this child view controller, you would call the get delegate to update the parent view. In SwiftUI, you don't need to do that. These property wrappers do it for you. Okay, so what if I want to share this to multiple views? In the previous example with at binding and at observed object, I'm passing it to a single child view. But what if I want multiple views to access this property? And what if this child view is not necessarily a descendant of the parent view? Well, there's another property wrapper called at environment object. In other words, it's in the environment, and it's similar to at observed object, but you share it across multiple views. So if I have a child view, or if I have any view that isn't necessarily a child view of a parent view, I can use that as an environment object to share this property to many different views. So if one of my child views updates, other child views could update as well. I don't need to pass it to it because they all share this at environment object. And you don't use this whenever you, if the view doesn't create or own the instance, then you don't use this at environment object. You would use, I guess I didn't show it here, but you could use at environment, which is the same as the at state version. So I kind of made a really, I guess, visual graphical way to kind of understand these property wrappers. So kind of just to recap, like SwiftUI, everything is declarative. I create a view by saying I want this view. If I want to modify it, I use a modifier, which are methods that I attach to my views, and it recreates a brand new view. And because everything in SwiftUI is a struct, if I were to change these properties, I would need to use these property wrappers to update my views. So everything that you've learned in UIKit, I've tried to cover most of it in my 2 lectures. But again, you can always just Google how to create views. That's why I didn't really want to go over it. You can always Google it. But it's important that we understand how SwiftUI works and why SwiftUI was created to replace UIKit. So it's important that we understand how property wrappers work whenever we create our apps using SwiftUI. So if y'all were to use SwiftUI for your hack challenge, you guys need to definitely try to really understand property wrappers. So there are 4 places in which a data can come from. Well, technically 5 if you're including networking, but I didn't include it in this case. So you can own it yourself. You can get it from your parents, or you can get it from your environment, or it's saved on your local disk. So again, if you own it, if it's an immutable value, then you can use a regular property. Ints, double, floats, those are just regular properties. You don't need any property wrappers for it. But if you want to change it, remember, these are structs. So if you want to change it, and if you own it, you would use at state. But this only works for mutable values, in other words, value types. But if I have an object that I'm passing to different views, then I would use at state object. And again, you only use that if you own it. But if the data comes from your parents, if it's immutable value, you can still use a regular property because, again, it's a struct. But if it's a value that you want to change, you want to use at binding, since this child view gets it from the parents. If you're using a reference type, then you would use at observed object. Third, if it comes from the environment, then yeah, I have it right here. So at environment is similar to at state, and at environment object is similar to at state object. So if it's a value that you obtain from your environment, then you wouldn't want to use at environment. But if it's of a reference type, then you would use at environment object. Yes.
If you have an app and you have multiple pages, or multiple views,
Mm-hmm.
And you have light mode and dark mode, and depending on which one, you change the backgrounds.
Yeah.
Is that preference, like you could have variables saying you prefer dark mode, would that be something that would be in the environment category, because every view would want to access that?
Well, you could use it in that case, but when you're doing dark mode and light mode, Xcode or Swift has this nice thing where you can, with all your images, with your colors, you can set, like, you know how you have this assets catalog? You can actually set individual values for light mode and dark mode. But you could theoretically use at environment because you're sharing it across multiple instances. In that volume example of that app that I was working on, I had different tabs. And because there are different tabs, I wanted to share, the most common case for using at environment is with networking. Because you want all of your views to use the same networking structure, because whenever you're using networking, you will create a class that you will call all these endpoints on. So you want to share that across all of your views. You want all your views to be able to access this network manager.
Would that be like static?
It's similar. It's not necessarily static, because I see what you mean by static though. But remember, these property wrappers are used to change views. Yeah. So now, if the data comes from your disk, this is a little bit advanced, but if you guys are interested, remember user defaults with persistence. Well, if you're getting this data and you want to use it for the whole entire app, you use the app storage property wrapper. You don't really need to worry about the single scene. That's only for like iPad apps or Mac apps. Oh yeah, the good thing about SwiftUI is that it's cross-platform. You can create iPad apps, Mac apps, even like Apple Watch apps using SwiftUI, which is really nice. And I'm not sure if Reed ever discussed core data. You can kind of think of it as like a database in a way for the front end. And in that case, you would use at fetch request. Yeah, that's it for SwiftUI. Does anyone have any final thoughts, questions? Yes.
Next week, I don't think I'm having enough fun with SwiftUI. So far.
Yeah, so the thing about SwiftUI is that I can't really teach everything, but I tried my best to teach you guys the core fundamentals. But everything I taught y'all here, if you understand it perfectly, then if you just go on Google, look up how to create this view, then it should, it'll all make sense. Yeah.
Also, if you do the hack challenge, you can do the hack challenge in SwiftUI, and then TAs who know SwiftUI like that.
Yeah.
Get out with learning more advanced stuff.
Yeah, and remember, it requires less lines of code, so. Yeah. But UIKit is important too. Don't forget UIKit. I start off with UIKit. Yeah, don't forget that. It's important.
I think to answer your question, next week we're gonna do other